So today we will talk about another loop statement called as a while. So for the for statement, it's more likely for you to use if you know how many records are there, or you have a list, then you need to process all of them. But there are some scenario, it's like you need to keep doing until you satisfy some condition, then you quit. So if that's the case, then you can use things called the while. The for and while sometimes interchangeable, but while they can handle some cases, probably for cannot handle. So the logic is like while you have some logic this, and you have the statement to keep processing, and once you've done this, then you get out of it. So for example, you have this one is I equal to 0. Say when I smaller than 6, then I will just for example, I will just print the I here. So if that's the code you just write and you run it, you will see you just keep printing 0 and Y. They never stop. Okay, why? So you can see over here when I equal to 0, the 0 is smaller than 6, right? So I will print it. And then for the next iteration, I is still 0, 0 smaller than 6. I keep just printing that. And so when you're trying to have some condition, you make sure inside of the statement, you will make the change of this value. If you never make the change of this value, you will just get stuck inside, and you never would be able to move out. So over here, if I have say I is equal to I plus 1, so in each iteration, I will increment the value by 1. In that case, I change the value. So you can see in the first round is 0. I print 0, 0 smaller than 6. I will print it. Then in the next round, I has been updated to 1. 1 still smaller than 6. I will do it again. Then I'll keep 2, 3, 4, 5 still smaller than 6. I keep doing, but when it's 6, 6 is not smaller than 6. So I would jumping out of this loop. So when we jump out of this loop, then this thing terminate. Okay. So to achieve the exact same task, for you can still say like I in range start from 0 to 6. Okay. Then you will print I. And when you use a for loop, they will automatically increment by 1. And when you use a while, you actually need to do it explicitly. So when you try to run these two, you will see they were just doing exactly the same thing. Okay, so in this scenario, it's much better just use for, because they automatically move these for you. You don't need to worry about how to move it. But there are some scenario you probably want to use while over for. So over here, I will introduce two possible scenarios. So first thing is, if you need to do some comparison with the previous value, and in that kind of case, you better to use okay, so it's not like this one. If you need to compare the previous value, you still can use the index with the for loop. But let's just think about one scenario. How can I find the square root of the 3? So for the square root of the 3, just let me see how can I draw a graph here. So you know let just try to use, if it's x, that's y, start with 0, 0 0.1, 0, 0.2. Okay, I just have this one. And y is equal to square of x. Okay, so let's, if we have this x and y is square of x, and if we draw the scatter, I think it should be a scatter, correct? It's not this one. I need to insert. Okay, here. So you can see the relationship between x and y. They're gonna have this monotonically increased curve coming over here, right? So when I want to know what's the square root of the 3, so if I want to know the square root of the 3, you can see it's above here, okay? It's kind of something, it's within this range, but we don't really know the exact value. So, and if we don't know the exact value, so how can I get the square root of the 3 by using the computer program to do that? But in the beginning, we can set up something called the lower bound 0 and upper bound 3. So let's say we have the lower bound 0 and called the upper bound of 3. So for 0, the square root of 0, a square of 0 is 0. When it's 3, the square of 3 is 9. So as we can see, this value, I want to find a number. Let's say it's a. And I want to know a times a equal to 3. I want to know the exact number of a. At the current moment, I don't really know what's the exact number of a at the current stage, but I know 0 times 0, let's say 0 times 0, that's equal to 0. And then 3 times 3, that's equal to 9. Okay, so at that moment, these 3, the value of y, the value 3, is between 9 and 0. So we will know for this monotonic increase property, I know a definitely gonna be greater than 0 and smaller than 3. Okay, it's within this range. Although I don't really know the square root of the 3, what is that, but I definitely gonna know it's within this range. Okay, so that's my first step. So that's the upper and the lower bound. Okay, but this range is really huge. So I still don't know where they are, because that range is really huge. But we can have some cutoff. Okay, so right now, let's see, between 0 and 3, I will try to check the number 1.5. 1.5 is between 0 and 3. So when I check 1.5, I will put 1.5 here. 1.5 here. And then the square of 1.5 is equal. So I will use this times this. It's 2.25. So over here, it's 2.25. And we can see in order to get the square root of the a, we know a times a equal to 3, and 1.5 times 1.5 is 2.25. So from here, we can further to narrow down. We will know the a is actually within the range 0.5 and 3 by doing the calculation, because when we have the 1.5 get the square of this one, it's 2.25. It's smaller than 3. So I will know the square root of the a, at least it should be bigger than 1.5, because 1.5, the square of this one is not greater than 3. So I will know right now it's within 1.5 and 3. It's within this range, right? So I will just update this lower bound in the iteration, in one iteration. So I just try to find something in the middle between this range. I will know, okay, because the lower bound of this one is smaller than 3, I will know it's on this side rather than on the left side. It's on the right side. So now I will narrow down to say, okay, square root of 3 must be within the range 1.5 and 1.3. So between the first, I know it's between 0 and 3. Now I further narrow down. I will know this value is between this range. So I start to narrow it down. But this gap is still huge, right? So how can we do? So it's the same story. Then I will just try to do the calculation. So this one is going to be, try to find the middle value between the lower bound and the upper bound. It's 2.25, okay? And then I will just try to calculate the square of this. What is this number? So for 1.5 and 3 within this range, I will try to find some middle value. It's 2.25 coming here. And the square of this one is 5. So when it's 5, okay, I will move it over here. Smaller than a, smaller than 3. Okay, that's in my first round. That's my first round. In my second round, I further to narrow it down. So based on this value, in the third iteration, we will know this value is already greater than 3, right? So in that kind of case, I will bring the upper bound closer to here. I will know a definitely going to be smaller than that, because the square of this one is already greater than 3. So I will know the upper bound should not be within that much. It should be like 2.25. Okay, so I will bring shifting. I will move the upper bound over here, and in the first round I move the lower bound over here. So I do this iteration, you will see I further narrow it down. So the square root of the a at the current moment, I know it's between this range, so I will change the upper bound is 2.25. So that's the way how I'm gonna do. Okay, so when this change to 2.25, I will still calculate the middle value between these two. Now it's 1.875. When I look at 1.75, the square of this one is 3.51. This one is still greater than 3. So I will know like square root of 3, this a, definitely cannot be greater than that, because if it's greater than that, then the value is actually greater than 3, so we were not doing it. So we will narrow it down to a now is within the range 1.875, okay, through this iteration. So I will further to narrow the upper bound to A75 to here. And then I will try to calculate the middle value between the upper bound and the middle bound, lower bound. So I will just, this one is in the middle value of this one, it's 1.6875. When I calculate the square of this one, it's 2.84. It's smaller than 3. since it's smaller than 3, we will know it's definitely going to be greater than this value. So I can bring the lower bound to closer. So in this case, I will move like 1.6875 smaller than A, 1.875. So through the calculation, I will know now the A is within this range. Okay, but this gap between this range is still kind of big. Okay, still there are a lot of opportunity or of choice you can have here. Then I will just update like 1.6875 and do the update. At the current moment, you will see this value, the middle value is greater than 3. So I will further to move the upper bound to here. Okay, so in the next iteration, so you can see this value is 1.6 at 75, smaller than A, smaller than 1.78125. It's over here. So after we keep doing that, we will see the gap gonna be smaller and smaller. In each round, the gap will be half of it. Okay, and after you go to some significant around, let's say the upper bound, when the upper bound and the lower bound, the difference, if it's smaller than, let's see, I don't know how much iteration they're gonna have. Suppose they have many iteration, and let's say between the upper bound and the lower bound, if their difference is smaller than this value, very small value, then we will say, okay, no matter whether it's upper bound or lower bound, it's very close. It's very close approximation, and we probably gonna be happy with this value, and we just stop over here. That's the procedure how we use computer to estimate the square root of the 3. So when it comes to the procedure to replicate the way we're gonna have, that's how we write in the code. Okay, so in the beginning, let's say we have lower bound, we will say it's 0, and upper bound at the current moment it's 3. So we will have while statement. Say if the upper bound minus the lower bound, as long as it's greater than 0.001, if that's the case, we just keep doing it. Okay, we keep bridging the upper bound and the lower bound. Okay, and then that's a procedure we're gonna have. And then for this one, we will have the middle value. So we will have the middle value is equal to the lower bound plus upper bound. It's in the middle, so it's half of that. And then it's depending on where the middle value would be. So if the square of the middle value is greater than 3, in our procedure, if this middle value is greater than 3, I will shifting my upper bound towards the middle value. If it's less than 3, I will shifting my lower bound towards the middle value. And that's the way how I'm gonna do that iteratively. So that's the logic. So if middle value times middle value, if it's greater than 3, so that's the logic operation we can have. So we will say now the middle value is already, the square of this one is already greater than 3. then when we get the square root of the 3, I will know definitely the upper bound can be shrink towards this middle value. Okay, else if in the else situation the middle value, the square of the middle value is smaller than 3, then I can shift in the lower bound towards the middle value. So the lower bound will be equal to the middle value. That's the procedure we're going to have. And then after several iterations, and finally when they have this one, I will print the middle value as approximation for the square root of the 3. So that's the things we run. And that's the value we get it over here. So if you go to the terminal, okay, not the terminal, it's go to the console. Just let me just run it again. Okay, if that's the value, you can do some verification. So you can see it's very close to 3, although you will never be exact 3, but it's kind of close. Probably I can have this one. That's just more straightforward for you. So the middle value times the middle value, square of this one, so you can just see it. So you can see when I breach the upper bound and lower bound by this threshold, over here, that's already decent approximation. But if I want to be more accurate, I can just say, okay, I want the lower bound and upper bound to be more accurate in the decimal place. I put more 0 here. I want them to breach in more narrow range until they jump out of this while statement. And if that's the case, you can see. So now comparing to the previous one, this one is more accurate, and I can keep just adding this one. Okay, and this is accurate already. 1, 2, 3, 4, 5, and 6 decimal place. Let's see for this one how decimal place. This is equal to 1, 2, 3, 4, 5, 6, 7. It's kind of 8 decimal place. So although you will never be exactly have the square root of 3, but by using this, you will see how this is gonna be changed. And inside this while statement, let's just try to run this one by one. So in the beginning, upper bound and the lower bound is between 0 and 3. So let's see when we do the debug to finish the first run. Now you will see now the lower bound has migrated to 1.5, okay, because 1.5 is smaller, square of this one is smaller than that. The lower bound has been 1.5 and 3. So you can see in this step, it has been within this range. And then when we run this iteration, so now the lower bound and upper bound between is 1.5 and 2.25, okay, in this iteration. And then let's just further run the iteration. Now it becomes 1.5 and 1.875, and then if we run 1.6875 and 1.875, so you can see that's actually goes through the procedure we're gonna have, okay. And if you want to see what's something in the middle, so we can have like a print the lower bound and also have the upper bound. We just print these two values to see how much iteration they went through to get this value. So in the beginning, that's this range for the first iteration, second iteration, and they keep doing and have enough iteration, they just stop over here. Okay, when we remove last decimal place, you can see they're gonna have fewer iteration, but no matter what it is, then that's the way how we use computer to actually calculate the square root of the 3. And you can see in the beginning, I don't really know how much iteration I'm gonna have, okay? But there's some criteria sitting there, and as long as I've satisfied these criteria, and then to be accurate in something I think is accurate enough, then I would not bother to do further calculation for this approximation, okay? So that's the way you're gonna see, and that's how you just try to do the calculation and writing the code for this while statement in some special scenario. And now I already finished the basic things for the coding, and actually it's kind of you start to already learn everything about the programming. Then the next thing is just like how you, it's like I already give you all the possible Lego chips, and the next thing is how you can use these Lego chips to create this model and create the stuff from these beginning Lego chips. And it's exactly the same Lego chip, but someone can build very fancy, probably even like a spaceship, and another person probably can just build a wall, very simple version, but all the chips are exactly the same. And for all these coding, they have just two fundamental blocks. One is the data structure, another one is the process. For the data structure, you need to understand the difference between number and text, and then for more advanced, you're gonna have list and dictionary data. And for this like procedure, you have first sequential, you just 1, 2, 3, and then beyond that, you just have the loop. You either use for or use while, and then you have the control like the if statement. Actually, the fundamental things, that's only all of this. But how you can synthesize then you have unlimited potential to do whatever the things you're really able to do.